Good morning. We have gotten some rain last night, so yeah, I had to take everything in, but now the rain has stopped. I put everything back out, and yeah, we're having tea on the balcony, and you are welcome to join us. Absolutely. Tea on the balcony. Mm, yes, as I was saying, good morning, and tea on the balcony. Wow. Anywho, I wanted to discuss how the world formed. Now, I'm reasonably sure you've heard of planetary accretion. If you haven't, that is the standard model for how planets form in zero G, orbiting around an established star, a new star, a new star. Planetary accretion is how planets form in orbit around a new star. Yes, the debris left over from the formation of the star, in our case the sun, starts clumping together under the effects of gravity, because gravity pulls things together. And in zero G, this leads to objects clumping. Particles clump into bigger particles, which clump together into even bigger particles, which clump together into even bigger particles, until eventually you have things the size of a bus. And then you have things the size of a Walmart. And then you have things the size of the greater Toronto area. And then you have things the size of the average right-winger's ego. And then you have planets. Yeah. Yeah. Planets. Planets are formed by accretion of the debris left over from the formation of stars. And in our case, we happen to have a G-class star. Those stars are fairly small. They're called yellow dwarfs, and they have a lot of debris left over, so there's a lot of material for making planets. And there used to be a lot more planets in the solar system, but Jupiter kicked most of them out, and the others merged into each other to create the planets that we now have today. But yeah, planetary accretion over a period of several tens of millions of years. And eventually, if you keep adding lumps together, eventually you get a big pile of lumps. Then you add several big piles of lumps, you have an even bigger pile of lumps. That's how planetary accretion works. Because yes, gravity is a thing. And all it really takes is a slightly irregular spacing of debris, causing two objects to clump together, exerting a little bit more gravity, which pulls more objects towards them, which cascades until you have everything pulled into a lump. Why is the Earth round? Well, again, gravity. If you had a mountain on the Earth that was 100 miles high, it would eventually be pulled down by gravity, because gravity pulls everything to the center. It doesn't pull everything down relative to the Earth. It pulls everything down relative to the center of the Earth being down. Which is why people can live in Australia and not fall off the bottom of the Earth. Gravity. Yes, I understand that flat earthers insist that down has to be relative to the entire planet. But that's not how it works. Down is relative to your position on the planet. If you're in Australia, your feet are basically pointed up at England. Your down is towards England, through the center of the earth. But people in England, their down is towards Australia, through the center of the earth, because down is toward the center. Just making sure that flat earthers understand this. That no, relative to Earth, down is to the center, not down below the Earth. Gravity is not an absolute concept. Down is not an absolute concept. Down is relative. And gravity is relative to the biggest center of mass, which in our case is planet Earth. So it doesn't matter where you are on the Earth, down is toward the center of the Earth. And I wish I had a globe so that I could illustrate this. No, I don't even have a ball, but if I had a globe, I could illustrate this. Okay. Imagine this fist is the Earth. If you're down here, down is toward the center. If you're up here, down is toward the center. Yeah. Gravity is relative to the biggest, most massive object in the immediate vicinity. The center of that object is your relative down. But anyways, that's how the Earth was formed. And that's how gravity works and how we can have a round Earth and have water stick to the surface of it. Gravity is a thing. That's also why we don't have square planets. Again, gravity. Gravity pulls everything down so that everything will be the same distance from the center of the Earth. And because gravity isn't all that strong, the process of pulling things down tends to be very slow. So yes, you can have temporary resistance of gravity, such as the Himalayan mountains, which are still rising and will rise for a few billion more years, but they're also eroding steadily. And if it weren't for erosion, they'd be about 40% taller. Something to think about. The Rocky Mountains in central North America also used to be much taller. Erosion has pulled them down. Gravity, yes. Anyways, I'm going to let you go. Take care, be well, love yous all. Okay.